Hello, this is Simon's Things on Thursdays. It's another edition of my mostly weekly live stream where we look at IoT stuff with Redis. So we're not actually in the middle of a project at the moment because we kind of took a break for the New Year and holiday period. And so what I thought I'd do is start the year or this sequence of live streams off with more of an introduction to Redis Stack, which is the Redis plus extra capabilities that we use on a lot of these streams. And also just quickly look at like how that could be used for some sort of IoT use cases. And also have a quick look at what hardware we've got that we're probably going to be using in the next upcoming live streams. So if you're not familiar with this series already, you can go check out previous versions or previous editions on our YouTube down there. There's a playlist with my name on it that you'll find. I do the weekly This Week on Discord show with other members of the team. And I do these shows mostly weekly on Thursdays. I was off last week because I was sick, unfortunately. So first one of the year now. So yeah, if you want to see what sort of projects we've built before on here, we've used Raspberry Pis, we've used Raspberry Pi Picos, we've used, I think, Arduino type devices. Then we've used all sorts of like buttons and different displays and sensors. And then on the Redis side, we've used lists and streams and search and JSON and all sorts of stuff. So yeah, that's what we have there. And I don't have too much of a solid plan for what's going to go on with these streams in the next few weeks. So I've got some hardware kicking around that we are going to use on the stream, but I've not really got too much of an idea of what to do with it. So if you are out there watching and you've got some theories or some stuff that you'd like to see, obviously I'll need to have hardware for it. But if there's some use case for Redis that you're interested in seeing developed or looked at on this this stream, then let us know down there by joining our Discord. And there's a channel in there for Internet of Things that is mostly to do with this show. But also, if you want to share like any IoT projects that you're doing or anything that you're interested in, there's quite a large community on Discord now. And yeah, those people will be interested and maybe able to offer you some help and suggestions if you need it, or just some applause and feedback if you've done something amazing that you want to share. So yeah, that's Discord. So what we're going to do today is, as I say, a sort of overview of Redis Stack, so kind of like a level setting stream. So we're not going to do any actual coding per se, and we're not going to mess around with any hardware. But just quickly, I wanted to sort of run through some of the things that we have got on the shelf for use in the stream here this year. So one that I've been using a lot on the streams recently is the little Raspberry Pi Pico W here. So this is essentially a microcontroller. It's not a complete computer like the Raspberry Pi is. You don't install an operating system on it. What I've been using it with is mostly the MicroPython runtime. So you can write code in Python that's familiar to quite a lot of people. And you can also write code in C, which we haven't explored on here yet, but might be something I want to try out. So these are great. Like a Raspberry Pi, they have these GPIO input-output pins that you can control and program and send data to and read things from. So we've used these with temperature sensors, light sensors, buttons, little displays, and all sorts of things. They're quite an interesting product. And the reason why I've been using them is, as you've probably seen, there's a chip shortage on, and these things are available pretty immediately if you want to buy one. So regular Raspberry Pi single board computers, like say the Raspberry Pi 4 here, these are actually currently really hard to get. It took me quite a long time to get this one because of supply shortages, and then when they come in stock, they get sold pretty quickly. But that's starting to ease up now. So hopefully we can look at some things with multiple of those Raspberry Pi actual single board computers. And I want to look at ways of using Redis to manage and orchestrate services that run and use multiple of those. And then I want to look at ways of showing you how you can manage and push software to those devices. So, you've got a central database that's managing one aspect of the application. And then, yeah, we'll look at a little bit of IoT DevOps stuff, hopefully in the future. If I can get like 2 or 3 of those devices, because obviously pushing stuff to a single node isn't that interesting because we can't show things like different roles or configuration or changing the role of what the thing does in the system through software. But we'll get a hold of a few of those at some point. The other sort of classes of products that I am going to be working with on these streams are increasingly companies, and I love Pomeroni in Sheffield. They are making things like this. So this is a little display here, and it has a few buttons on it here. And this display has multicolored backlights, and you can draw on it, or it has fonts. And then you just pop your Raspberry Pi Pico or Pico W in the back, and now you've got something that's on the network and has a display and has buttons. So we'll look into using this sort of thing for how to display data from Redis, and then how to maybe use the buttons to acknowledge something's happened and change the state of something in the database. And again, those can be coded in MicroPython and C. And away from the Raspberry Pi ecosystem, I have also got one of these, which is from a company called, that's quite reflective, from a company called Seed Studio. And we've used their devices before. We've used their sensors a lot with the Pi Pico W. They sent us a nice, what's called a Grove kit that allows you to just plug sensors in and out and in and out without doing any soldering. This thing here is more like a complete little terminal device. It's got Wi-Fi, it's got expansion port on the back, it's got small ports on the bottom for adding things and powering it. It's got a nice little display. And then this thing in the corner is like a sort of joystick and button. So you can do anything with this. You could write games, you could make like a smart thermostat terminal display or whatever. So that is more of an Arduino class device as well. So that's again programmable in MicroPython or C. So yeah, that's kind of what we've got on the shelf. I've also got like a stock of buttons and LED lights and things like that. So hopefully we can use those, because when you're working with a device like this, there obviously isn't a screen attached. So you want some sort of input hardware that's a bit more compelling than just let's read the console in VS Code or whatever. But yeah, that's for another day. So today what we're going to do is focus on sort of reintroducing Redis Stack. So if we picked up any new viewers for the new year, hello. You might not be familiar with what Redis is. And if you've been watching this for a while, you'll have seen some of this material before, but it always bears repeating. So what I'm going to do is go ahead and share my desktop here. And hey, we've got slides. So this isn't a slide presentation. It's going to be a lot more interactive than that. But I wanted to start off with some slides. So we'll just skip away from this one. And we'll talk about, so, okay, what is Redis and what is Redis Stack here? Because that's the sort of common thread on this theme. It's the thing we're going to be using more weeks than not. So Redis Stack is a key value data store. So it's a sort of database. It's in the class of databases that is key value. So rather than storing things in tables and having a SQL-like interface, it stores values against keys. So you can think of it as a great big hash table. So I like to think of it as, if you look at the picture in the background there, so the lady there, she is working in the Library of Congress in Washington, DC, sometime in the 1970s. And she's using their indexing system. So if you think of Redis as sort of that big thing on the wall that has all of these boxes, so each box will be like a memory location. And if you think of each box having that white label on the front, so like its name, that's its key name. That's how we identify one box from another. We can give them arbitrary names. And then when you pull them open, what she's got in there seems to be a load of index cards. So she's got a sort of ordered data structure in there. So that one might be a list. And one of the cool things with Redis is its key value store that has data types. So we'll look at what that means in a minute. But that basically means you can store different things in there and treat them differently. The sort of pertinent, interesting things about Redis is, we'll start at the bottom. It's accessed via a network, so it's a server process. So you can run it on a little device like a Raspberry Pi 3 or 4. You can run it in the cloud, and that's how we're going to get started with it. Or you can run it locally on your machine. And there's different ways of getting hold of it. We'll look at the cloud. You could compile it from source. You could get it from Docker and from Docker Hub and run it in Docker. And that's a really good way of getting going with a development environment and trying out different versions of Redis and stuff. And then the other sort of key things to note here is that Redis keeps all the data in memory. So what does this mean? It means if you want to store how many gigabytes worth of stuff in there, you need at least how many gigabytes worth of memory, plus some overhead for your operating system and just housekeeping. And that sort of scares people because, oh, I'm keeping the data in memory. What happens if the server reboots or something goes wrong? Well, people tend to forget that Redis is also configurably persistent. So there are persistent strategies. You can turn them on and configure them. So you could have it essentially log every write command and then replay that when it reboots. You could have it log every command or the state of the database every so many commands or so many seconds or whatever you like. And then the other thing that people get sort of confused by is, well, okay, how do I store more data than I have actual memory, actual RAM? And the answer to that is by clustering and sort of sharding the data set. So you'd have multiple instances of Redis server running on different machines. That gives you a bigger pool of addressable RAM. And then Redis has a way of figuring out for a given key which server that key actually lives on at a given time. Redis clients SDKs will understand that. And that allows you to scale the database by just adding more and more cluster members or shards. So yeah, that's kind of a good visual for Redis in my mind. Think of it as a great big hash table. So at a very, very basic level, one of the simplest things you can do with Redis is set a key to a value, and we'll just assume it's a string value for now. So you can go away and just use whatever key naming strategy you want. It's kind of important that you have a strategy here because keys are generally the way that you're going to get data in and out. So if you don't know the key for something or you can't infer it, then you're kind of stuck. So here I'm just storing different types of animals with their names. So I can say set cat to mocker, and we can store, imagine there's a box in memory, and we're going to call that box cat for the minute, and we're going to store that string mocker in there. And then I can do similarly set dog to latte, and the same thing happens for dog. And then we do get cat, we get the value that was stored at cat back. So the command line interface over there on the left is something called the Redis CLI. So that's one way of interacting with Redis. If you're familiar with other databases, it's similar to the sort of interface where you issue SQL commands. But here we're using Redis, so obviously we do Redis commands. And Redis can be fitted into any programming language you like via what's called a client or an SDK, if you think of it that way. And that generally maps these command names onto functions in the programming language. So for Python, there might be a function called set and get and so on. Some clients operate at a higher level and do sort of higher level operations where you might say to it, add something to a priority queue, and the client will implement a priority queue using Redis data types. Others use the search and JSON functionality to allow you to save documents and then find them not by the key, but by properties that they have. And we'll look at that in a future live stream. So that's your basic setting a key to a value. And if we move on from that, we can see that key value stores may or may not be a new concept for you. So it may be a new concept in terms of where you put the data for the data to rest, but it's probably not a new concept if you're already coding. So if you're using Python over there and you've ever used a dictionary, that kind of looks like a key value store. So imagine you had a thing called users, and that was a dictionary. So that's kind of like an instance of Redis in some ways. And then we can use these key names, so the count, mathwiz, and so on. And we can set values and we can get them back again. So that's basically the same thing as we just did, here. So Python, dictionaries. If you're working in JavaScript, so you're working in Node or JavaScript in the browser, you've probably come across using objects, and it plays out pretty much exactly the same way. Um, Obviously, in these languages, you can store arbitrarily complex things inside here as well, not just strings. So far, we just looked at strings with Redis. Can we store more complicated things? Yeah, well, we can. We can store quite a lot of different things. And with Redis, those things come with their own set of commands to manage them. And those commands have their own set of behaviors. So if we start up in the top left there, we've been using strings. So we just stored a simple string and recovered a string. We're going to look at some other data types today. So we're going to look at the list, which models a doubly linked list. And we could use that for, amongst other things, a queue or just keeping things in order. We have a hash, which models a sort of flat name value object. So that's kind of like a Redis inside a Redis. So there's a key value space inside a key value space. We have a stream, which is more like an append-only log of hash type objects. So if we wanted something where we just keep putting things in it and it timestamps them for us and tells us when it happened, that's really, really good for event processing. So you'll see that used a lot on this series of live streams because quite often what we're doing here is building something with like one of these little devices and a sensor, and it will be sending information into the server periodically. And we want the server to be able to timestamp when that thing happened and store the data so that other things can later on read from it. We've got things that model a set in Redis. So that's a mathematical set. So you put members in there. So A, B, C, D, E, F, whatever you want to put in there. And one of the properties of a set is that it doesn't allow duplicates. So if I put in A, B, C, 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 D, E, F, I would still only have one instance of C. So this is useful for a couple of things. It's useful for deduplication, and it's useful for counting distinct things, which is something else that we do on this stream. One of the things that we can build with a lot of these little devices will be things like a building occupancy counter. How many people have entered the building today, or how many people are currently there if we've got one monitoring exits as well, or how many people have come in the last hour, what's that flow rate, all of that sort of stuff. Or imagine we're a traffic camera as the other sort of classic example. How many distinct vehicles have we seen today if we've got a reliable source of license plate reading? And the way that we work with counting things in Redis is we can either be absolutely precise, so we can use something like a set that has a memory overhead because we have to remember every distinct thing we've seen in the set. And if the identifiers for those things are big, like, I don't know, that frames the data for a frame from a video or something, then the size of that set gets quite big and everything lives in memory. So we're going to need a lot of memory. So there's other things in Redis, such as the hyperloglog, which is a probabilistic data structure that uses hashing to approximate the counts of something. So it will count distinct items. It won't store the distinct items in the data store. It will hash them and store them in a data structure that's way more efficient at the cost of a bit of accuracy. So if we wanted something for like roughly how many cars have I seen today, or what's the flow rate today, give or take the accuracy of a hyperloglog, we can use one of those and save a lot of memory. So we look at those sorts of trade-offs on the stream too. I won't go through all of these. Sorted set is a way of building a leaderboard, amongst other things. It keeps a set of values in order by score, and the database orders them for you. Geospatial is something that we haven't actually looked at yet on this stream, and I'm going to want to do that, which is basically, find me things that are near a given set of points. And we can also do complicated searches with geospatial and search. So we could say, I don't know, find me like 5-star rated cafes that do a decaf latte within 2 miles of this location. Bit fields are a kind of low-level thing, so a very efficient way of storing data. So if you can imagine you wanted to build something like a permissions mask for, say, a Unix-like operating system where you have, user, group, and everybody else RWX type permissions. You can use bit fields for that sort of thing, and then perform operations on them to sort of say, if these bits are set and not those bits, then will allow this thing to happen. Or you could use them to store things like a map for a game or something like that. And similarly, bitmap is a sort of similar construct. So Redis gives you all of these data types and they come with behaviors, which is great because that means that you don't have to write things like, oh, I want to append something to a list, or I want to get the 10th element of a list, or I want to atomically add 1 to a value in a hash. It's going to do all those things for you. So what else do we get with this thing called Redis Stack that we're using here? So Redis Stack is a package of the sort of core Redis and some other things that give it some extra capabilities. So going left to right, the thing on the left is what's called Redis Insights. That is a graphical tool for exploring the data in a Redis instance and working with it. It gives you the CLI, it gives you a sort of point and click interface. So there we're looking at some hashes in Redis. And it can connect to Redis pretty much anywhere, locally or in the cloud. And then Redis Stack gives you these extra capabilities over here on the right. So there's a search capability. Earlier I said Redis was a key value store, which it absolutely is. But that generally means that you have to know the key or be able to infer it in order to get the data out. So if I know, for example, that I'm storing data about users and I know the user ID, I might have a key name like users:1. And when user 1 logs in, I can get their record based on that. But what if they log in by, say, email address or some other property? The search capability allows us to index things so we can say, okay, go find users in the part of the key space that begins users:, who have a value of a field email that is set to whatever value is provided. So search allows us to do that. It also allows us to do more complicated stuff like geo search, full text search, and so forth. JSON gives us the ability to work with JSON documents in Redis. So rather than storing them as strings, we can store them as complete JSON documents and then get them in and out of the database and work with them atomically. So this is good for IoT type use cases because we might be storing a lot of information about an entity in a single JSON document. So imagine we've got like a warehouse, and warehouses have zones, and in each zone we want to know the temperature and the humidity, and we want to know maybe what sort of stock SKUs are in that zone and how many we've got of them. We might have that in quite a complicated JSON document. And the JSON capability gives us the abilities to manage and update parts of that document atomically. So we can just say, increment the stock for product 1, 2, 3, 4 in zone whatever, and it will do that, or get us just these values. And when we're working with tiny IoT devices, that's great because it means that we only pull the data we need from the database. We're not having to pull the whole thing and then remove loads of it in, or just get what we want in like a server component and then send that to the little device. The little device can interact directly with Redis and it can get just the bits that it needs. So we look at that quite a lot on these streams, both as a way of storing like sensor data, but also as a way of triggering events. So, when something in a JSON document hits this trigger point, we had in a previous stream, like for example, if the temperature in a room exceeds a certain amount for a certain number of observations, and we were storing like the current temperature and the number of observations and so on, then go tell a sensor to turn the fan on for a while and cool the room down because it's gone beyond a temperature threshold. So, in the IoT world, we can use it for that sort of thing. Redis Stack gives us additional probabilistic data structures, so the ones that trade off some accuracy for some storage space. Again, this is interesting in IoT because we're quite often dealing with infinite streams of data. So like traffic data, or I guess tweets is another classic example, or temperature, humidity, or whatever it is you are monitoring has kind of like no start and no end. So if you're doing things like trying to count how many distinct people you've seen today on your sort of badging system or your camera system or whatever it is that's just looking at street, then you probably want to think about whether you really want to be 100% accurate versus whether you want to save some data, some memory, and use a probabilistic data structure. So in Redis Stack, we have some additional ones that include a Bloom filter for checking set membership. So have I seen this particular thing before? And it will tell you, no, I haven't, or maybe I have. That's something that we've built out on this stream before. If you go check out the previous streams on YouTube, then you'll find that I built out a Bloom filter with LEDs. So we actually built the sort of algorithm and everything, and then showed how it works in Redis inside. There's some other interesting data structures in there. So there's something called a top K that keeps a sort of scoreboard of the top however many things in a sequence at the minute, or a series. So you could use that for like trending data. And then Redis Stack also gives us some graph database capabilities. That's not something that is particularly my area, so I don't tend to cover that on these streams. And also time series, which we may or may not look at, as it also lends itself to IoT type data. So yeah, what we're going to look at on the remainder of this stream is, okay, Redis Stack kind of looks interesting. How do I get started with it? So we're going to go get a Redis Stack instance. We're going to use the Redis Insight tool to have a look at the data. And we're just going to have a look at a couple of sort of past project code examples and see what we can do with them. So I'm going to put the slides away now, get rid of Keynote, because we don't need that anymore. So let us start at the very beginning. So let's assume we have nothing and we want to get a Redis Stack instance. There's a few places we can do this. So I can go to redis.com here and I can do try free. And what that's going to do is get me up and running with Redis Cloud for free. So I create an account. I can do it with Google or GitHub or filling out this form. And we have a tier that is completely free and it doesn't expire. You basically get 30 megs worth of memory, which is plenty enough to play around with this sort of stuff. And it's great for IoT projects because it's hosted on the internet. It's got an endpoint that you can access, so you don't have to build and manage your own server to have devices go talk to the database. So that's what we're going to do. I'm already signed up, so I'm going to just log in here, and I am hopefully, after the Christmas period, still knowing my password. So I've got an account here and it's completely empty. So we don't have any databases or database subscriptions. So I'm going to go ahead and create a new subscription here. And what we can do here is, we can start paying for things, but we're going to start with the free plan because that is plenty for these sorts of projects. And it's a great way of sort of getting into this. I said that this is Redis in the cloud, and it is. One of the things that is sort of important with thinking about Redis to get the benefits of the speed of having all the data in memory is to put your code close to the database. So the chances are you're already putting code into one of these cloud platforms. So we support hosting the database for you on AWS or Google Cloud or Azure, and you can pick different regions and so on. So I'm just going to go with the defaults here and put mine in Northern Virginia and on AWS. You don't need an account with these cloud providers to do this. We basically provision this for you and you'll just end up with a URL. But obviously, if you're putting server-side code into a cloud, you want it close to your database. So pick the one where you are already deploying things. We're going to go for 30 megabytes, which is free, and we don't need to do anything else. So we'll just create that. Oops, sorry, let's call it IoT projects. And we'll create a subscription called IoT projects. So inside here, I now need to create a database. So let's just click new database and we'll call it things on Thursdays. And what type of thing do we want? We said we wanted a Redis stack. So we want Redis with these extra capabilities. And we're not going to worry about any of the durability stuff. And we are going to need a user and a password. So I'm going to deal with that off screen in a moment. But basically what we can do is now hit activate database. And you see this little clock up here. That means it's off building the database for us and setting it up. And what we're going to end up with when it's done is we're going to end up with an endpoint that we can use. We're going to end up with Redis Stack. So we're getting this version of Redis and these versions of the extra capabilities. And we'll have 30 meg to play with. And I am going to copy that password. So, okay, so it's gone green now. So our database is active. We can start using it. And up here, we've got an endpoint that we can start using. And what I'm going to do is connect to that with the Redis Insight tool. So if you don't have Redis Insight, you can go here. It's easily found on redis.com. And you can download Insight. It's a sort of Electron app, so it runs on your machine. It has like I'm on a Mac. It sits in the dock and it runs. Well, here it is. Let's start it up. It runs and it starts like this. And you won't have any Redis databases configured yet. You can see I've got a local one here on my machine. I've got one in the cloud that I use for some other stuff. And we want to get set up with this new one. So let's do add a Redis database. We'll do add it manually. I have got that password that I want to put in there. And I need to go get my host and my port from Redis Cloud Console over here. So I need this. That's my host name. So as you can see, it's in AWS US East where I asked for it to be. And when I replace this with this, and the port it's running on is 13797. And we'll call it things on Thursdays here in Insight so we can see what we're doing. My username is default and my password is whatever password is set up for us. So let's try adding that. Okay, so it's added it. And as you can see, it sees it as a standalone database. It's got all of these capabilities, so the ones that we thought it had. And hopefully when I click on it now, we go into a key browser. Let's see if we can make this a little bit bigger. We go into a key browser and we can see that there's nothing in the database. So I have a fresh, completely blank database that has all of these extra capabilities. So I can now work with this in a couple of ways. I could say I want to store something in a key, and I could select a string, and I could say my name and store Simon in there. Add that key to the database. We can turn on an auto refresh over here so that this will pick up, there's one key in the database now. It's called my name. And if you click on it, you get this value over here. So that's one way we can work with Redis. I'm going to turn that off so it stops flashing around. Another way is we have a built-in CLI. So in the slides earlier, I was using the Redis command line interface. That's built into here. So I could also do set someone else to say my colleague Justin. And then when I refresh key space here, you'll see that someone else is now set to Justin. So not rocket science, but this tool's enabling us to both view and manipulate stuff in the database. So the thing that people tend to use Redis a lot for, and you'll see up here, is if I go edit, if I go edit this up here, I have something called a TTL value. So that's like time to live. So if I set 10 seconds time to live, what we'll see is when I refresh this and refresh this, that starts to count down. And when that hits 0, what you're going to see happening is, oh, that key's not there anymore. So Redis timed out that key or expired it after a time period that I configured. People use this a lot for caching. So if you want Redis to remember the result of some complicated thing that costs you a lot of processor time, or if you want it to remember an API call from an API that you're spending money on every time you call, it's really, really good at that. So in a nutshell, that's kind of like your basic use case for caching. We generally look at all the other things that you can use Redis for because it is a general purpose data store. So yeah, so we've now got a database up and running. We've got a key space here. I can do stuff with this. Let's delete that key. And now we're back to an empty database again. And I can do all sorts of different things with it. So really quickly, I was just going to show a couple of the basic data types, and we won't go into too much detail on what you can do with them. But one of the things that we do quite often is model something that looks like a set of name value pairs in what's called a hash. So if you imagine I'm storing something like a user record, and we'll say I want a hash called users:1, and my hash is going to have a field called username, and we'll put in Simon, and we're going to have a field called email, and we'll put in Simon out whatever.com, and we're going to have a field called account type and say I'm like an admin or something. So when I add that, I now have over here a single key in Redis, users:1, and then I have this data structure stored there. So I have username, email, and account type. I can go ahead and create more of these. So we'll just create one more. So let's do users:2, and we'll do username. Let's stick with Justin here. And email, and we'll do justin@whatever.com. And then I can hit add key. And what you'll notice here is now we have these two hashes. And I've said that they're users hashes. And I'm sort of creating a standard here where I'm saying, let's use users: some user ID. And we'll store these things. But this is kind of freeform. Redis doesn't enforce a schema. This is not a relational database table. So here, Justin's user doesn't have that account type field. It doesn't need it. The database isn't going to enforce it. So you've got a lot of flexibility here. And it also means that your application kind of needs to manage that. So if your application goes looking for this account type key and it doesn't find it, you need some sort of code to deal with that. But the flexibility of this is you don't necessarily need to have a hard and fast schema, so you can evolve things quickly or store flexible data. So this is broadly hashes, and I can access things by the key name. So if I know the user's ID, I can let's do a command down here. So I can do hgetAll to get everything from a hash, users:1, and back will come Simon and all of the things in the hash. I can also start modifying it. So I can do include by, let's say users:1, and let's say number of logins, and let's say I've logged in. And what does that do? I've incremented a field called num logins by 1. Well, there wasn't a field called num logins in my hash. So Redis has done the sensible thing and gone away and created it. And it set the value to 1. And then if we wanted to track the number of logins, every time I log in, I can just run this command again and again. And what you'll see is that this comes back with the right value. It just keeps adding 1 to it. So we can track things like numbers in hashes. So hashes are kind of good for storing flat name value pairs. We can also, with Redis Stack, do search over these, which is beyond the scope of today's live stream. But we could basically tell Redis, keep an eye on all the bits of the key space that begin with users : and which are hashes, and basically build full text indices around some of these data fields. So we can do searches for all users that are an admin type, or all users that have some derivative of Simon in the name, or everybody at the whatever.com domain. There's lots of content on the YouTube channel about using Redis to search like this, and it is something that we'll build out in these streams over time. So that's hashes. They're kind of like a flat map. I'll keep those around, actually. The next thing that, or the next question that people might have will be, well, okay, that's a flat map. What if I've got something more complicated? So yeah, a lot of things these days are stored in JSON documents, and there's a lot of benefits to that. And JSON documents are arbitrarily complicated. So we can have things like nested objects and arrays and so forth, which we can't do in this sort of flat name value world of the hash. So what we have in Redis Stack here is a JSON capability. So if I clear this down and do JSON.set, and let's do, let's call it profiles this time, or profile 1. And then this uses the JSON path syntax, which is a standard for navigating JSON documents. Again, we've covered it in previous streams, and when we use it on a project, we'll come back to it. But I'm going to say I want to store something at the root of an object. So I'm setting a JSON object at this key. And I need some, let's use single quotes. Need some quotes, and I'm going to need something like, let's see, username, Simon, and email, Simon at whatever.com. And then let's do something a little bit different, like attributes becomes an object containing account type, which is admin, and let's say none logins, and we'll set that to like 4. And I guess I need to close that off as well. So that says, okay, so we've now set the key profile 1 to this more complicated data structure. So when we update this like this, what we'll see now is I have Insight is sort of partitioning the key space for me by colons. So it's using colons as a delimiter. You can configure other things to use as delimiters, but we kind of like colons. So here in the profile section, I have one key, and it's a JSON key. And when I click this, what you'll see is I have this JSON document, and now I have a bit more structure than I had in my hash. So I can put the account type and the number of logins inside an attributes object. And inside there, I could have like an array of things, like maybe email could be an array of possible emails that I want to use to access the system, or this system knows about for me. And suffice to say, in the same way that we could increment this number inside a hash, we can do that in a JSON document. We can also get all of the JSON document back, or just parts of it. So if I wanted, for example, just the email, so I could do JSON.get profile 1, and then I do a JSON path for $.email. Then what you'll see down here is I get a list of, or an array of things that match back. So I get my email address, and then in a Redis client, that'll be parsed out into an array in the native language that we're working with, so like Python, Node, C, whatever. So yeah, you can store JSON documents here, which is very, very handy. The search capability also works over JSON documents. So similarly, we could tell search, go watch all keys that begin with profile, and expect to find JSON documents in those. And inside those JSON documents, if they have, a path that looks like username, then index that. And if they have a path that looks like Atra's account type, then index that, maybe as a tag field, which is one that has a limited number of values. So we could say, account types are admin or user or dormant or not fully signed up yet, or whatever the different states of our accounts are. So yeah, we can store JSON documents. That's going to be really handy. And as I say, this sort of behavior of the ability to get and set just parts of them without pulling the whole document down to the device is really handy for IoT stuff when we are using tiny, tiny devices on potentially slow or expensive networks with a limited amount of memory. So that's JSON and hashes. I'm going to do something that you should never do in production and type flush all, which will delete everything in the database. So now I've got an empty database. There's nothing here again. So the other use case that we use a lot in this this series of streams, so with IoT devices, is we want to be able to count things. So we want to be able to count like the number of times an event happened, or the number of things that triggered our sensor, either like just the number of times it's been triggered or the number of like distinct things that triggered it. And there's a couple of ways of doing that with Redis. So one of the ways, as I said earlier, is to use a Redis set. So a set is a list of, well, it's not a list, it's a set. A set is a collection of members with no duplicates allowed. So you imagine what this means. I can here in Redis do sadd, which is set add command, and we could call this staff members. And I could say the staff members that I know about are Simon, Justin, Savannah, folks that you see on stream, and Steve for now. And there's two things happening here. So I've got an empty data store, and I'm saying to it, add these things to a set at the key staff members. But there's nothing at the key staff members at the moment. It doesn't exist. So when I do this, Redis is going to go create that for me, and it's going to come back and tell me how big the set is. So we added 4 people into the set, and as you would probably expect, that means that we get 4 people because they're distinct people. If I then refresh my display here, you'll see that we now have 1 key, we have a set, and if I click on it, you can see who's in the set. So Simon, Steve, Justin, and Savannah are in the set. We can then ask Redis, like, how many people are in the set. So scard is the cardinality of the set. It's going to be 4 people, so as you'd expect. We can then go and add some more people. So let's do sadd staff members. We've also got like Alex, Suze, Josephine, Nava, I. So that's some more people that we've added. So I told it, let's add 5 people. And it said, okay, 5 people were added. So we can now expect, if I go back to scard, us to have 9 people in the set. And when I refresh this, scroll down, we've got all of those people in that set. So what then happens if we see one of those again? So if I do sadd staff members, Simon, and then this time let's also add Tim. So this time we got 1 back. So what does that mean? Well, it means 1 new member was added to the set because Simon was in there already. So we've now got a set containing 10 people, not 11, because duplicates aren't allowed. So sets are kind of good for the count distinct problem of, how many different things have we seen? There's other uses for them in Redis, but this is kind of the one that we do a lot with IoT. We can also say to it, have we seen a certain member? So S is member, staff, members. Have we seen Guy? Yeah, we've seen Guy. Guy's a staff member. We get 1 back. Do we have a staff member called Frederick? 0. No, we don't. Or we don't at the minute. So we can also ask it, as well as how many of these have you seen, we can ask it, is this person or is this identifier in the set of things you've seen? So we can basically say to it, have you seen this before? We can also say to it, test members, staff members, just give me all of the staff members. So here we're getting basically all 10 of the staff members back again. So that's sets, and we use sets a lot on these streams for counting things when we want to be what's called deterministic. So when we want to be absolutely right and know that there's 10 people, and we're okay with incurring some memory hit for that. So here our set's pretty small. It's like this figure here is the amount of memory that is taken up to store this data structure. So it's like under a kilobyte. But if we were storing lots and lots of things, like all of the vehicle license plates that have passed by a camera today, this might get arbitrarily large and we can't really control that. And we may or may not really need to know exactly that we've had 10 things go by. So there are other data structures in Redis that help us out with that. So one of them is what's called a hyperloglog. It deals with just counting things. So the set here is doing like two jobs, right? It's doing how many things have we seen and have we seen this thing? So if we have a hyperloglog, it's more memory efficient, but it allows us to approximate counting. So we gain some memory back, quite a lot of memory actually, for a big data set, and we lose a bit of accuracy. But that's generally okay if we want an approximate count. So like how many people have liked this tweet when it's in the hundreds of thousands, just saying like 13,800 is okay. If you go look at our YouTube channel number of subscribers, it's always a pretty round number because I guess YouTube's approximating it. So hyperloglog is good for that sort of thing. And in IoT projects, it's good for efficiently maintaining sort of trend data for like how many things have we seen recently. Redis, let's clear this. The Redis commands for hyperloglogs all begin with PF, which is after the name of the mathematician that came up with the formula for it. So I can do PF add, and I can say, let's say number of license or PF add license plates. And we'll say we are tracking license plates, and that license plates look a bit like this in the geography that we're tracking them at. So what you see now is, again, I didn't have to create that data structure. Redis has gone out and created it. And if I go look at it here, it doesn't make any sense because the hyperloglog isn't storing the actual data. So we're not storing this AAA123 here. We have sort of hashed it away into a representation of itself. And that's where we potentially lose some accuracy in how many different things we've seen, because we're not storing the things that we've seen, but we gain a lot of memory space back so we can count lots and lots of things and get an approximate count that is not far off the actual one. So if I go and do similarly PF add license plates like AAB and then like some other ones, then what you'll see is we've added things to there. The one there, I think, means that at least one of these was new. It modified a bit in the underlying data structure. And then we can say to it, PF count license plates. How many license plates have you seen? And it's seen 4. So it's actually accurate at the minute. But as the data set grows, there will be like a margin of error in that. So we'll get a sort of trending result. But what won't grow in proportion with the data set is the size of this key here. So this key size will top out at about 12K and it won't grow any bigger. So we are sort of getting the trade-offs we're making here are we can't get the data back. So I can't say to it, okay, what license plates have you seen and get these 4 or these 3 and that one thing back because they've been hashed away. They don't exist anymore. But we can say to it, roughly how many have you seen? And based on the algorithm it uses for hashing these away, it can tell us how many it's seen. And the advantage is it won't blow out our in-memory data store. So we can efficiently afford to count an arbitrarily large data set and get an approximation of how many things are in it. So that's sort of solving one of the count problems for us. The other thing that the set was doing, so if you remember the set here, I could do S is member staff members and say Simon, and it will say Simon's a staff member, and I could say is something like Ruben a staff member, and Ruben is not a staff member. So it can tell us that, and it can tell us that with absolute accuracy because of this. It is remembering all of the things that we put in there. So the bigger this data set gets, the more memory it's going to take up. So in Redis Stack, we have a probabilistic data structure that helps out managing the potential problem here with the size of the data set. So if we were wanting to say to something, have we seen this thing before? And it was okay if the answers were maybe we have, or absolutely no, we haven't. Then we could substitute the set for a Bloom filter and save ourselves a lot of money, a lot of memory. Memory can be money. So we can save ourselves a lot of memory, again, at the cost of, we never get a positive yes, we've seen it, because the Bloom filter uses hashing, and with hashing comes hash collisions. So you might store two values in it. They might hash to the same set of things. And then we can't tell the difference between them, but we can tell that we've seen one or the other, or possibly both of them. We've got a lot of content on Bloom filters on the Things on Thursdays on YouTube. We actually built one with LEDs, which was kind of a fun thing to do. But you wouldn't build your own, you just use the one built into Redis Stack. So if you needed this sort of functionality, so an efficient set membership thing, let's take a look at how that compares. So we could now do bf.add, and we're going to call this one something like, I don't know, let's say, well, again, like license plates Bloom filter. So we want to store license plates again. We'll do AAA 123, and we've now got a new data structure. License plates BF, that is a Bloom filter. There's no visualization for that in Redis Insight here just yet, but we can work with it and we can tell it's a Bloom filter. So we've added something there. Let's go and add some more things. Let's do, I think we can do bf.multiple add, license plates Bloom filter, and let's do RRR 999 and E123. And okay, it's gone away and added those. And then we can basically say to it, bf.exists, license plates. Yeah, we can say, have we seen RRR 999 in the time period that we are storing these things in? And it will come back and say 1. Now, with the set, the 1 here meant, yep, absolutely seen it. With the Bloom filter, because we've hashed the data away and I can't get it all back out again, there's a possibility of hash collisions. And when I went and created this here, I just used bf.add for sort of speed. There is a bf. I think it's called bf.create. There's a command that allows you to dimension and set up a Bloom filter. So you can basically configure what your desired error rate is and things like that. So you can tailor these to your use case, but I just went with some defaults here for speed. So we can basically say, we might have seen that license plate. And then we can say bf.exist license plates bf, and let's do ggg123. Now we get a 0 back, and that means we absolutely have not seen that. So we can tell that that's the case because when that string got hashed away into the Bloom filter to go check what's set in the hash table that is representing this data structure, nothing came back. So we know that we've not seen that string or actually anything else that hashes to the same hash positions. So we can be positive that we haven't seen it. And we can say there's a strong likelihood that we have seen that. And we can configure how reliable that likelihood is. And the trade-off with this data structure is memory versus reliability. Again, so you can opt to use a bit more memory or not. So depending on what you're using to count things or know if you've seen things, there's like 3 data structures going on that might be useful. So that's sort of quite a lot of things about counting. The other thing that we use a lot on this stream in Redis is we have situations whereby we have like multiple of, say, these devices, and they're generating something, or multiple jobs are being generated and things need to handle those jobs. So we need some sort of producer consumer situation going on, and we need a queue between them. And there's a couple of ways you can do that in Redis. So I'm going to clear this database out yet again, and we've got nothing. And clear my workspace here. There's a couple of ways we can do this. So Redis has a list and it also has a stream. So we are going to look really quickly at the list here. So if I want to create a doubly linked list of things, and my data is pretty simple, so it can be represented as a string or mushed into a JSON document in a string, then I could do, for example, lpush jobs and then some payload that goes onto there. So I could have like clean bedroom or something, and then I could do lpush jobs, go shopping, and lpush jobs wash the car. So what have we got now? If I refresh the key space here, we've got a key called jobs, shows up as a list. And then when I click it, you'll see I've got wash car, go shopping, clean bedroom, and they're in order. So they're, in the order that we put them in there. So imagine I'm like creating jobs. I'm some sort of thing that hands out jobs to people for whatever reason. I can push these jobs onto there. And again, there's no schema here. So I can do lpush jobs, and then I could do something like, let's see. Something like this. I think. There we go. So I've now put a string encoded JSON thing into the queue or into the list, and we could interpret that as saying, oh, room 123 in our hotel needs some more towels. And when we refresh this, you'll see that I've now got a string value, a string value, a string value, and a string value that has JSON in it. So again, it's kind of on the application as to how to interpret these. And then if I want to sort of move modes and go from being a producer of jobs to a consumer of jobs, I can use this pop command. So I can do, rpop. So L is the sort of left-hand head end of the list. R is the right-hand tail end. So we can get the oldest job off the list. So I can say rpop jobs, and I can say how many I want. Let's just say I want 1. But the oldest job on the list was clean bedroom. So I've now, if you like, taken the job clean bedroom, and it's gone off my list of jobs. Somebody's taken that. If I do it again, you'll expect go shopping. And then if I do 2, you'll expect the other 2 jobs. And now, there is no key anymore. So when the list is empty, Redis cleans up. So what happens if we do rpop jobs now? We get nothing back because there's nothing there. So that is a way of building a queue. There are what's called blocking commands on here as well. So you can tell it to wait for something to appear in the list and then pop it when it immediately does. So if we have a situation like now where there's nothing in the list, we could run command brpop jobs, and it'll wait until something gets added to the list, and then it'll pull it off the list. And that's one way of building a sort of queuing environment. Another way of doing it with a bit more functionality, and it's probably one of the more complicated data types in Redis, is to use a stream. So let's clear this and sort of figure that out. So a stream's kind of interesting from IoT perspectives because it models a sort of append-only log, and you can put things in there, and Redis will timestamp them for you and keep them in order. And what you put in there is a series of name-value pairs, so like a Redis hash, and you can encode stuff in there in however you like. And then Redis Streams provides a way of saying, oh, get me all the things that have happened since a certain time period, or give me the next thing that happened after this last one that I've seen. And it also allows stream consumers to work in groups and sort of parallel process their way through an event stream. So we use this a lot for buffering like infinite sequences of events. It's quite a complicated data type. There are a lot of streams, live streams about Redis streams in the YouTube. So go check out the previous episodes of this show to have a look at that. And I'll also come to it at the end. There's some courses that you can do that cover streams. But broadly, we're going to add something to a stream. So streams commands all begin with X in Redis. So we're going to do xadd, and we'll call it, let's stick with the jobs metaphor. And then we're going to do room 1, 2, 3, and we're going to do job towels. What I'm doing here is telling Redis, go add an entry to a stream. And oops, I always forget this. Go add an entry to a stream that has a couple of properties. It has a room and a job. And the stream key is going to be jobs. And then, oops, what have we got? Stream key is going to be jobs. And then I'm using this asterisk that says to Redis, hey, give it a timestamp. So I could provide my own ID. I'm going to say to Redis, give it a timestamp of when you think that event occurred. And what we get back is the timestamp of that thing that we just added to the stream. It's got a -0 on the end, and it's a millisecond timestamp. So Redis can cope with these things coming in really, really quickly. So if we were to add lots of these at the same time from different clients, we might start to see this dash go up. So it'll keep them in order no matter what. So if another thing happened at this timestamp, you'd see -1, -2. So we can go away and add another job. So let's do room 456, and the job might be taxi. And then we might have like a number of people if they want a taxi for 3 people. So what have we got in the data store here? If I refresh this now, we've got a stream called jobs. And when I click on this, there we go. What we'll see is we've got a more complicated view in here now. So we can see the entry IDs that it's created. So when these entries were added to Redis, and then we can see a table view of what's in them. So again, there's no fixed schema. So the fact that this one's got a number of people because it's a taxi job, and this one doesn't have a number of anything because it's a towels job, doesn't matter to Redis. So this is kind of like a list, but the things in here are a bit more complicated. And the thing with the list is accessing things in the middle can get difficult. Here we can access things by timestamp, or we can access things by sequence. So I can say, yes, let's just add another job. So let's do, we'll have a job of room service to room 100. So we should now have a third thing in here. We've got towels, taxi, and room service. So if I then say, okay, let's switch from being like the front desk at the hotel, the people that create these jobs, to the people that are working the jobs, I might want to say xread. So get me get me something from the stream. And I am a little bit confused by the syntax there. I'm a bit rusty. So what we're going to do is, when we don't know something, we go look it up. So here we go. Xread, all Redis commands have a command page like this on redis.io. Xread's quite a complicated one. So what we're going to do is xread count one. I want one message back. I want to read from the stream called job. We can read from multiple streams. And then I need to give it an ID. So I need to say, okay, what was the last ID of a job? So the last, in this case, it's going to be timestamp that I saw from this stream. And I'm just going to give it a low number. I'm going to give it 0, which is like the oldest possible timestamp. And what you'll see when I execute that is that what I get back is from my stream jobs, I get back this entry, so the one at this timestamp, and it's go do towels for room 123. Now, when I popped the thing off the list, when we were building a queue with a list, what you noticed was the size of the list got smaller. With streams, that doesn't happen. So consuming things, reading things off the stream doesn't affect the state of the stream. So if we wanted to use this as a queue, we need a mechanism to then basically mark that job as done and delete it from the stream. But if we want to use this as like sort of timestamp log that we can go over again, or we can have multiple processes that do different jobs reading from this, it's perfect for that. So I can then sort of say, okay, well, I've done that one. So give me the next job. So the way I tell it, give me the next job, is I take the ID of the job that I had before, and we paste it in as the ID here. So we can say, I've seen this job, give me the next one job or the next one thing whose ID is like immediately greater than that. So we'll get that taxi job and so on. Or I could have said to it, give me the next 2 jobs, and then we get that room service one. Or I could say to it, give me the next 3 jobs, and we still get 2 because there aren't any more jobs. So if I then say to it, well, okay, I've done all of these jobs and give me the job whose ID is greater than this one, there won't be any. So we at that point know that we've caught up with the work stream and there's nothing else to do. And again, there are blocking commands for this, which allow us to wait until something happens. So we could basically say, hey, kick around and wait for a few seconds. And if a job appears that's a new job that you haven't seen before, then great, here's the info for it. And if it doesn't appear, then come back to the application and say, okay, application, what do you want to do now? So the application might then say, I don't know. So we will use that quite a lot. We'll use it for a number of reasons. So we'll use it because it keeps things in order. We'll use it because with IoT, it allows us to not have to bother with a real-time clock on the devices. So like, tiny little pi pico W or something doesn't necessarily, we don't necessarily want to deal with setting NTP time on that every time it boots up. And we'll just use server time for the events. So Redis is handling that. It's handling the order. It can handle a huge flood of these things coming in and put them in order. And then we can process them at our leisure and maybe look at what's happening in this event stream. And there's a series of videos on the YouTube that covers this from Things on Thursdays. So we can look at, for example, is room 100 generating a lot of jobs, or which room has generated the most room service jobs? And we can use other Redis data structures like the sorted set to keep a sort of high score or a worst offenders table of which room is asking us for the most things. And that's a scenario that we built out with a couple of the Raspberry Pis and streams and sorted sets in a previous video. So yeah, what I wanted you to take away from today's video is, number one, go get yourself a cloud instance of Redis. Start here at redis.com and do try free. It's very, very easy to get up and running with. Grab yourself a copy of Redis Insight, because that's the best way of looking at what's going on in here. It's just extremely useful when you're debugging with these little IoT devices. You can just have them like log stuff into the database and view it there without having to mess around with being connected to the device and look in the console. And that, Redis has these data structures, and Redis Stack offers these additional capabilities that kind of make IoT projects with Redis really fun and easy to get into. So you'll notice that with a lot of these data structures, I don't have to like go and create them and define a type and define a schema. And then if I figure later in my project, well, actually, I need to move things around in the schema while I'm still sort of feeling out what I want. I don't have to go change that. There's no overhead of all of that. You can just get on with doing things. So, I find it quite fun for building flexible projects like that. And then, lastly, what resources do we have that you can be looking at until we come back with another project next week? Well, we've got a few things. I like pointing people at our Discord. So this is the Redis Discord. It's at discord.gg/Redis. And we have an IoT channel in there. We have a channel for all sorts of things. And basically, join us, come talk about anything you're doing with Redis. You can get help from the team. It's not an official support channel. And we do tend to focus on developer coding type topics rather than, say, scaling or DevOps type topics. But there are people in the community that can help you with those too there. Then the other thing that is good to go check out is here at university.redis.com. We have our free courses. They're all online. They're completely free. Most of them are video based. And if you pass the final exam on those, which is a series of multiple choice questions, and it's open book, you can use the internet. We want you to be successful. Then you can get a certificate and you can put that on your LinkedIn profile as a credential. So you can say, you've successfully passed any one of these Redis courses. But what I'm going to call out specifically for the IoT stuff is go check out the Redis Streams course. It covers that streaming data type in quite a lot of detail, way more than we're able to go into in this stream here, or perhaps in a coding project. And it looks at things like, handling bad data in the stream and removing what's called poison pill messages. It looks at things like consuming the stream collaboratively amongst a load of microservices, and also things like memory management. You've got essentially a data structure here that could be storing things that go on forever. At some point, you want to get rid of the old things or start timing them out, or move them onto another disk-based store or something. And it looks at all of that end-to-end management of data in Redis streams. So University is great for that. And then finally, we have got our schedule here. So if you want to see more of these live streams, so this is what we've got coming up this week. We've got an office hours, which is not on Twitch and YouTube. That's actually in Discord. And then we're back on Friday with This Week on Discord, where we answer questions from the Discord community on a sort of not live basis. We look through Discord and figure out what questions would be good to discuss on a live stream format. And then the team sort of discusses them and solves them amongst ourselves. So that's something to look out for. If you want to suggest a project for me for next week, I don't have anything at the minute, so please feel free to come chat with me in Discord. Otherwise, I'll just figure something out. And we'll be back next week with something that's more like our normal stream, which is a bit of live coding, a bit of building things in hardware. And sometimes it goes tragically wrong because working with hardware can be a little bit tricky. But I have rebuilt the entire desk for this year. I had some issues last year with unreliable power, it turns out. A lot of these little devices, so like when you start putting screens and things on the Pi Pico, they're even more sensitive to having a good, clean power source than they normally would be. So I think I've solved all of those. We'll come back for MicroPython coding with the Pi and the Pi Pico. Might get brave and try a little bit of C. We'll definitely try some stuff with external displays, so LEDs, sensors, that sort of stuff, arcade buttons. We'll basically always use Redis as a sort of orchestrating, controlling data store. So we may also write bits and bobs in Node.js if we need the odd like server-side microservice, or we could potentially have a go at that in other languages. So I don't know very much about Golang, but we could maybe try that, or perhaps some Java. So I am very open to ideas. But yeah, that's it for today. I think that's a good point to wrap things up. So if you want to follow along with these in future, go get yourself a Cloud Redis instance. It's free. Get yourself Redis Insight and maybe consider looking at least the streams course. But none of that's prerequisites. You can just come along and kind of watch me try and figure it all out. So that's it for today. And yeah, I'll see you next week with hopefully a new project. Thanks very much.